Okay, this problem is a lot easier than it looks. Consider the equation that gives the minimum stopping distance d in feet for an automobile where v represents the automobile's speed in feet per second, s represents the driver's response time in seconds before applying the brakes, and m represents the coefficient of friction between the tires and the road. Enter an equation for which the solution is the speed in feet per second of an automobile with a stopping distance of 200 feet, a driver's response time of 0.5 seconds, and a coefficient of friction equal to 0.8. Okay, so an equation for which the solution is the speed. This is kind of a confusing statement. I'm going to return to this in a moment. But really all that's happening here is they're telling us the stopping distance. We recognize that the stopping distance is which variable? D. Stopping distance is d. So this 200 is going to go in for d. Driver's response time of 0.5 seconds. S represents the driver's response time. So this 0.5 is going to go in for S. And then coefficient of friction is equal to 0.08. Coefficient of friction, m represents the coefficient of friction. So that is a lot of lines here, but that's that. And so this is the 0.08 that's going to go in there. Okay, so D is the 200. VS, V we don't know what it is, but S is 0.5, so 0.5 V plus V squared, we don't know what V is, so we're going to leave it, over 64. M is the coefficient of friction, that's the 0.8. Okay, so all we've done is read the definitions of the variables and plug in the information that they've given us. We didn't plug in for V because they didn't give us that, and here's where this statement comes in. The solution is the speed. So the solution to this equation would be to get V by itself, and if we could do that, then we would find the speed that we need. But we don't even need to do that. They're not asking us to solve for it. They're just asking us for this. So this is what we're going to enter into the box. 200 equals 0.5 V plus V squared over 64 times 0.8. 0.8. And done.